I'll slide on to the electrical section for this evening. It's one that a lot of people I find are very hesitant to do anything with. Yes, electricity can hurt you and can definitely kill you in the wrong situations. Electricity, though, can be something that we can all do reasonable repairs on things. How many have ever had a lamp that quit working and they just threw it away and stuff? Lots of it. How many people have had a tri-light that when the light bulb's flickering, you get mad and go buy a new light bulb, put it in, and it's still flickering? Those are common things that happen to homeowners. These sort of things are very fixable. Extension cords. How many people have an extension cord like this around the house? Probably everybody here. I hate these. These are the main cause of a fair bit of fires that go on in homes. They're not rated to carry heavy loads. They're okay if you want to feed something extra like a lamp, or say your Christmas tree, you want to light it. But if you want to do some ironing or something, or have a small space heater, this is not what you go and get. Look for something that's a little heavier gauge. Air conditioners, predominantly, there's extension cords on the market. How many people put a window shaker type air conditioner in? It sits in a window or a door, and you always end up having to find an extension cord for it to get to the outlet. Very rarely there's an outlet very close to them. I had a cord, but somebody took it on me, where the ends had actually burnt on them from the connection. You ever notice how heavy the cord is that comes out of an air conditioner? That's because of the amperage that that machine pulls. The more it draws, the more heat it does. That's why ends like this will burn up. That's why I usually recommend a heavier extension cord in those aspects. They make like a power bar type cord that are specifically designed for air conditioners. Those sort of things aren't common knowledge to a lot of people. They just assume a cord's a cord. Most cords, they go by the gauge of the wire. This is what's called 14-2. It's what's common in most household wiring. Anything built in the last 20 years uses a 14-2 or a 12-2 wire for almost everything except for stoves and dryer plugs. Furnaces are a whole different gauge if it's an electric furnace. They're quite heavy. They're usually a 1/0 or heavier. 1/0 is almost the size of my little finger.
Do you need an extension cord? I have an extension cord in my truck.
Pardon?
Do you need an extension cord?
No, there's odds and ends of them around.
Okay.
Just I had one that had the end that was burnt. And it was burnt because of an air conditioning unit that kept starting and stopping, and it runs to the point where the cord actually starts to heat. And usually at the connections of the cord, that's where they'll fail, because usually there's a blade type receptacle that goes into here, and there's just two blades in some of these. Some of the lighter cords will have just the two blades that the blade actually just touches here. So I think this one has two on each side where they actually go between. So you're getting more contact surface for them. Some of the older homes have this style of screw-in fuses. That actually, believe it or not, was one of the better fusing systems in the world because they are fairly accurate. Then they went to breaker style, like in most homes now. That panel there uses a breaker style, which is a little lever that can be reset. If you have a breaker in a panel that's been tripped quite a few times, they become overstressed and they do not trip properly, or they prematurely will start to throw. And it's because the contacts in them have either been too hot or they get stressed from being tripped, and a lot of people throw them back on and they have a heavy arc and it puts them back under a severe load. I find if you've got a breaker that is troublesome to reset, you should have it replaced in a panel many of the different ways that we have problems with things are connections. Any of the times that we've added something to a system, if you have more than 12 on a circuit, which is your outlets along, that's what code allows, is 12. It's different in some aspects for like kitchens or around sinks. You need a ground fault interrupting circuit and a ground fault outlet. These are designed that they can be tripped. You've seen these with the resets and that. You can check them. You can hit the test button and it will actually trip it out. That way, any sort of grounding or arcing will set this off. It's a protection point. You'll find a lot of exterior plugs for cars they're required on. A lot of older homes don't have them. We put them in a lot of the renovations we do. The older homes, if they have just a 2-wire system, this doesn't work properly. You can put this stylus in, but it will not act properly. You'd pretty much have to run a new wire. I would run a 12-2 to the circuit because it does carry a fairly heavy load if you put the block heater and happen to have an interior car warmer or a battery blanket. Some vehicles actually have 2 block heaters in them with a single cord. Regular outlet looks just like this. And the difference between these two is the one with a T-slot is a 15 amp. Some of these can be 20 amp. These aren't rated as high as these. You'll find these predominantly in a lot of kitchen areas, around kitchen counters. I always put them in the laundry areas as well for your washing machine and a deep freeze because of the loads that they draw. If you take a look at them, you can distinctly see the difference in those. In a kitchen application, you'll find the heavier gauge ones, you will run them on separate circuits. I usually run kitchen outlets on one single circuit per outlet usually. Sometimes you can put 2 or 3 and it's not a problem, but if I'm doing just 2 plugs in a kitchen, I will split the circuits so that they're in 2 circuits. So that means that there's a breaker on each one. So 1/2 of the plug will trip on one breaker, but the other half will still work. If you look, there's a spreader bar between the power on them, which is the copper colored screw. You can snip that bar and it makes it a dual circuit. The T-slots in them negate the heavier amperage for them. Light switches. Anybody got the old porcelain clicker style that make a real snapping noise when you throw them?
I have the push button. The old.
Yeah, that's a rarity. And it still works well?
Yeah, it works very good.
Yeah, because they have a heavy rocker switch in them. If they had a grounding circuit, they're still quite a usable piece. A lot of the old light switches are like this style or this style. They only have the 2 screws. They don't have a grounding circuit. Anything new in a switch has a screw on them for your ground. So you would have a ground that comes to the box a lot of the time, and you can see them over there when we have a look at it. There'll be a wire that runs to the box itself. If it does that, you don't have to put it on here. But if you're using a watertight box or a plastic service box like these, always make sure that this gets grounded. These have a ground lug in them, but I don't like using them. I like using the one that's directly to the plug. These ones will come with a single switch here, and then there's holes in the backside of a lot of these switches. You can take a piece of wire nowadays, and this one I believe has a gauge on it. A lot of them do. Yeah, if you set your wire, it'll tell you how much to strip off of it. And then there's a small hole here the wires will just push into. You don't even have to put them on here. They will lock in.
So if you wanted to change the light switch, like in my old house, most of my light switches work quite well, except for one I find I don't really like how it behaves.
Yeah.
So I'd like to switch the whole works of them, so you could just put in these.
You could put in these. I wouldn't suggest using the small holes for it. I would use the screws. And you can see in the backs of these where they've got for it. And if you look on the one side here, it tells you where the gauge is for the length of wire that you would strip.
See, that's what I think is happening with mine. My wire that's stripped is coming off of that. I think I could maybe just fix that, but I kind of thinking I'd like to just put new ones.
Oh,
Yeah.
these ones, honestly, well, I have to, not
Oh, yeah, there's no idea.
the switch.
The switch.
Yeah.
This is too modern for me. It's going in a couple of places. I have to push it.
Most of the switches nowadays have that option that you can strip the wire and bare it and just plug it into that. If you take that switch and you bare the wire to that, and then they've got the small holes, and it will not pull out. You can use a small piece of wire. If you notice beside it, there's a little slot. You can take a little piece of wire and depress it. It allows the pin that's holding it to come back, and you can take the wire out. It takes a little bit of work to figure it out and monkey around. Most of the time, I don't suggest you change wiring and such on those while they're hot, because it will give you a zap.
Yeah, but shut that.
If you're at all worried about things like that, have little testers like this. Home Depot sells them, and a lot of Canadian Tire and that. These testers are pretty foolproof. It'll tell you which side is predominantly the black wire on two of them is the hot one. So if you go with this, so that's the hot side right there. It beeps and flashes red. Everyone see that? As well, this will tell you if a cord is hot. That means there's power going there. And if you unplug it, it goes green, just stays green. So if you have someone with you, you go to the breaker panel, have them turn off breaker if you don't know the one that it is, turn the power off to that circuit, and I always say to people, test it. I've seen circuitry that's powered from two different sources. That's a nightmare in older homes where people have just kind of randomly gone down the line. I've seen 3 and 4 rooms where they're all fed off of one line. Just snakes around. My house was a prime one. It took me forever to fish out wires in walls and redo some of that. In some instances, it's better off to hire an electrician to come and feed some of those circuits properly for you. It can be a bit of a project to find ways to drill through spots that aren't going to be that hard to work with to get power to areas. Make certain that your electrical service, the panel, has enough room to add circuits. And an electrician will probably be able to tell you if it's physically doable. Sometimes it's not. I always found tools like this, and this is a handy little one. A lot of people look at it and they go, like, how is that? If it's wired properly, you plug it in and it lights these two lights. So 2 ambers. If you read the little chart on it, it will tell you if you've hooked it up right. I think under $15.
What's it called?
It's just a tester, like a plug. If you ever do an electrical install on a new house and Manitoba Hydro comes and inspects, one of the tools he carries is that. He walks around a brand new house and plugs it into the outlets. That's how they can tell if the electrician that's run it has it proper. And if it fails on any one of those, and it tells you what you've done wrong in a lot of instances. So if it's just a plug-ins, that's a very simple, easy way to test that you've done it right.
So I had to replace the plug on my block heater in the car.
Yeah,
Would that tester be able to show you?
no, but for a block heater, something like this
Yeah, that's what I used.
is all you'd need. And you probably had a black and a white line, and a green would be the center one between the 2 conductors. You'll find on these,
I did it all and it works because my car was out in the cold one day, but then it started. But originally I didn't know how to actually test that I did it right. So would one of these actually show me that I did it right?
that won't.
But that one?
No. The only way you'll know is if you were to actually take and go back down to the block heater
Okay.
and test at the block heater with an ohm meter, which is,
Like my brother has something that when I did I did the same. And he came along and he tested with something and said, yeah, that looks.
yeah. A block heater, you can't mess up because all it is you're heating an element. So all you're doing is running the power down through the element and then back up. So whether it's flipped one way or the other, it works the same. There is a proper way. If you look on the screws on that piece, they're different colors. One is a copper color and one is silver. The copper color gets the black, the silvered one gets the white, and the green one goes to the ground side of it. The ground will always be the large, ugly, rounded sort of terminal. That's the one that gets the green wire. Or in household wiring, when you take a piece of wire and strip it out,
Yeah, that's actually what the fuse on did, was stripping it without actually correcting the wire.
yeah, that's where that's a pair of pliers that are designed specifically for stripping wire. It comes with the different gauges, and it's got a hole that actually, when you put it on to strip it, and especially multiple braided wires, these are a solid core wire. So if you notice, there's holes through there, and they're different sizes. So this one, you would just go here. It is.
I'm not gonna tell you how long it took me.
Just try it on that. And there again, it's under $15 for that tool.
That can be easy when it's cold.
Did you go to the largest hole? No.
What's this one here?
Yep. You went to one size too small. So,
So it's gonna cut the plastic and pull it off.
yep.
Your copper.
They work quite well. And they've got a cutter on them as well, so you can cut that. And like I say, if you go to just the first one. And it's also got a thing on the end of it, so that when you go to put on it makes the little loop on the end that goes on the screw. And it's just, so it's just and it's actually spaced out about the right distance. And that's, you find a lot of electricians use Klein tooling. It's very, very good quality. This little tester will save you the world of jumping around going, ooh, wow, that one stunk. And it's,
I had a plumber that went, ooh, that way when he had to replace my, because he didn't test it, he thought it was
yeah.
soft,
And
it wasn't.
these have just got a small button that you push in the end of it. And once it goes, this just fits into the outlet. Like I say, electrical shocks, the regular 110 on the average won't kill you unless you've got a heart problem or pacemaker, definitely it may. But if you get in water or damp areas where you're grounding yourself up, it can kill you. The higher you get, like on 220, and that, it's a lot more severe. 110 though, through a transformer, like in a fluorescent light, no, that's a whole different story. You have a transformer that's upping the voltages in it, and that can really hurt. Capacitors that they use for starting them and that store power even after the lights shut off. So I always shut the power off and turn the switch off and on, and it unloads the capacitor on it, and then you can take the lights down.
Why is Fasteners 220 volts and normal housing 110? Why is there a difference actually?
You come from a country where it's all 220. It also runs, I believe, on 60 hertz, which is the cycle that the power runs at. 220 is actually more efficient to run. We've run on 110 in North America forever. The standard in Europe is 220. They vary between 60 and 70 hertz, depending on the area of Europe and that you get into. There are adapters that you can use for it. Anything that you find in commercial applications usually run on 220 or higher. And they can be single phase, which means its power is fed through one side, or three phase, which they run on three sides of things.
That's the duty tools and stuff is 3 phase and
Yes.
welded and stuff.
Yes. That's predominantly the difference between North American and European. Everything we've got here is on 110. It's a more economical grid to run. The 220 grids can be a little more work for the service people. But they're basically all the same transformers and such. It's just here it's all 110. And that same power line you see running with the transformers on, they can hook a transformer and drop 600 volt off of that. They can put a transformer and drop just enough for your house, for your 200 amp service and that.
Okay.
And that's how they change it up, is with the transformers. Things like your light. I was talking about this light. Sometimes the lights are cheap enough you can throw it away, but if it's, say it's an older family heirloom that you want to continue to use that, you can buy a kit. I think I dragged one out. How many of them have this style of light with the little copper pot and that in them? That's this portion. You find on these a lot of the time where the cord goes in them. You can feed the cord into it. Or the bottom comes off them, and there'll be a knot tied in the cord. You can untie the knot, pull this up high enough. You can see there's 2 screws in it, so it's pretty much foolproof. Even I can do that. And when you look at the it's simple to do. If it looks like this when you got it on your lamp, if you wiggle the copper portion, it pulls off. And basically what you see is this, and that's the portion you're replacing. And it comes with the little twist knob that goes on, and you'll see it's a little threaded unit. These are very inexpensive. You'll find your tri-light that keeps going is just a larger version of this, and it's a ceramic piece. And it just threads on to the torch light or whatever it is you're using.
So are the screws color-coded? Like, how do you know which one?
This will have a silver screw
And the copper.
and a copper screw.
Okay, so black and white.
So it's black and white. This one is beside each other configuration. This one is on either side of it. So I mean, pretty much anybody, if you take the book that was given to you there, is in the section actually step by step with the pictures of doing it. So I believe that's in there if I remember correctly. And if you just hold it and wiggle it like that, it comes apart. Just, yeah.
387.
It was in the original book that I had. I don't remember. Maybe a little more than I pushed it on there fairly good.
Yeah, of course.
And it just. So I mean, the old family heirloom lamp doesn't get thrown out. Pardon me? The cardboard stays in it. It insulates against the wire. It's touching the side of the lamp and shorting.
But if you're just replacing it, do you just replace that piece?
Yeah, if you want to maintain the pieces of the lamp that you're looking for, just take and you can buy just the center piece.
Okay.
I buy them as the kits because half the time it's just as cheap to buy that as. And like I say, the tri-lights come with the larger socket that you can replace the tri-lights with. Tri-lights are where the bulb, you go one, low, medium, and bright. And actually, the wife gave me heck because I've got one in the living room that started flickering the other day, and I should have brought it and we could have changed that out. But they're relatively cheap and reasonably, anybody can do it.
Yeah, my mom just threw out a tri-light, like an old one that has been in our family for a while. I just texted her. I was like, I can fix it, don't throw it out.
Yeah. Like, I've replaced them in them for people. Remember the old ones that had the big glass top with it supposedly looks like marble in the bottom that had a little switch that you turned on and.
Hers was a touch.
Yep. I've repaired those.
I just didn't realize, no, because when I looked at this thing, why? But I don't know anything like that.
No, if you pop them apart, like you can go ahead and pop that apart if you like. And there again, it's not something that you would throw out then. You know, you can relatively inexpensively put it back into service for yourself. And did they have the one for the lamps in there? They've revised that book a couple of times since I've did the initial review on it.
When do they probably be ready?
It's pretty easy to do ones like that. You've only got 2 wires and it's not going to, even if you do flip the wires, it will still work.
Will it make it like what?
It won't cause any problems for it. It'd be different if you were on a circuit where you're feeding a bunch of outlets or something off of it, but you're just feeding the lamp. And it's a 2-wire. It's the same as like an iron. They're just a 2-wire. You'll get a lot of radios and such.
492.
Okay. Whew. You had me sweating for a second there because I was certain that it was in the book originally. And they're a fairly detailed picture. Like it gives you a step-by-step.
For your small extension cord that you were talking about,
Yeah,
if you did happen to overload it, would it get warm or anything?
yeah.
Would that be an indication?
You should never run them under a mat or something. An extension cord's designed as a temporary fix for something most of the time. Entertainment centers and that, where you're powering a lot of things, I always say to people, try and find a heavier power bar and feed it with the power bar. They predominantly have a heavier cord on them. Instead of, you know, taking one of these and then plugging another one into this one to get enough outlets at your TV and DVD players and stereos and that. They don't take a lot of power individually, but if you start running multiples of them, or your PVR, your television, maybe a game console's running, game consoles, a lot of them will take a fair bit of power. So that's why I usually will state, if you're going to have your fancy DVD center, put a power bar in there. It's a lot neater way to put your cords in than things sticking in and out all over. And you're protecting. Power bars, expensive ones, have a bit of surge protection, but a lot of them with just a toggle switch aren't really surge protection. The toggle switch is just like a breaker in the house. It takes a fair bit to whack it to overload it enough to shut off. Actual surge protection has a battery. We use them at work and that for computers, and they're a lot more money than just a power bar. There's only a few power bars on the market that are actually surge protected.
But I don't think there's a big issue with needing surge protection in the toilet, correct?
We do in high heating and high cooling portions of the season. I've actually seen in Alexandria, they had what's called a brownout. It's where the power does not actually go off. The power drops low enough, it'll still start things, but it will not run things like refrigerators, deep freezes, and that. So what happens is the motor's trying to start in those appliances, but they can't, and they work under heavy, heavy load, but there's not enough amperage there to actually spin the circuits. So it creates heat and burns things up. And that's, well, I've seen quite a few in my lifetime, probably half a dozen or so that I've seen around here. Lightning storms where the power goes off and comes back on quickly. Those sort of things can hurt computers and electronic equipment. Part of what we are on our electrical grid, it takes hits closer to you to cause a problem. Like if it hit a transformer or that, it's more likely to do damage at your home. But like I say, the brownouts are worse than lightning strikes sometimes. And that happens if the power grid gets overloaded. Everyone's got their air conditioners running flat out. We have a bit of a lightning storm where there's some surges in the power lines, and then a transformer or something can't feed the grid properly, and it drops all the voltages on the lines. It's like if you try and start an electric motor and you don't have enough power to start your car on the thing, and it goes whir, 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 whir. And then if you ever looked at that wire going down to it, you would see that wire would actually start to go limp because it gets so hot. You've got an amperage load on that, and yet it's not turning the motor and utilizing the power that's there. You're basically causing a dead short. So the power has nowhere to dissipate. So it just sits and powers that line. So that's how an element on a stove works. It just gets redder and redder and redder if you don't control the voltage that goes to that element. That's basically what happens when the power drops to a certain point. Things that you're trying to operate can't spin up to speed or what have you. I mentioned about gaskets for sealing houses and around electrical outlets and such. These come in a kit. A lot of the times for external power boxes and that, they send you these gaskets. if you've got an older home and you're trying to stop leaks and that, these go under those electrical covers. And there's a little hole in the center that pops out.
So it's just behind the plastic.
Just puts behind them.
Like insulation.
And it will help stop air infiltration around those electrical boxes and into your home. Those ones come in a kit. It's a package of about 8 or 10. They're relatively inexpensive. That in combination with the little pieces that are about this size with the 2 prongs, you pop them into the electrical outlets and it stops any of the air that comes through this mechanism out here. Because you will still get air that'll come through these, but if you buy the little plugs that go on them, that helps as well.
So you need the ones that are like protected from
Child-proof. And like I say, these are the sort of things that when I did the energy retrofit program, when I worked for Beep and that, we would put in a home at that time. And it's all percentages. You take little pieces, average staple in a poly, the little 1/2-inch cut that you get there will give you the equivalent of 1 cup of water a year into your home. So if you cut down on all of those little infiltrations of air, you're starting to be able to control the moisture levels that are coming into your home, and you're actually making better use of the warm air in your home. You're not bringing in so much of that cold air. It saves on your heating bills, and it's one way to make the home a little more comfortable. You eliminate drafts. How many times have you sat at one spot in your house and you found a draft either around a window, or sometimes if you go around with a candle, you'll find around the electrical outlets, switches and such are where you'll see drafts. And that's where the gasket kits, they make them for light switches, and I have used the light switch ones on multiple gang boxes. This is what's called a 3-gang box because 1, 2, 3 for your light switches. They come in all kinds of different versions of them. If you're adding an electrical circuit and you don't want to cut the wall up all to that, they make a renovator's box that fits like this. You cut the hole in the drywall to this size, and when you push it through and you put your screwdriver on here, these little tabs come up, and when you tighten it tightens up against the drywall. So what I've done is cut the hole in the wall. I use a long bit. Make sure you've got nothing below. Pop the hole through, and you can run the wire up from the basement. Run it into the electrical box. Run it through your joist cavity to the basement to your electrical panel. Put in the panel and put another outlet somewhere that you didn't want to cut a whole bunch of stuff or tear the wall all apart. They make a few different versions of this. They make an octagon box as well. So if you're doing something in an attic or a ceiling space that you're wanting to put another one in. It's a little harder to get moisture protection and air barrier on exterior walls and ceilings. Predominantly you'd use something like that on an interior wall. Ideally, if you're going to go up into an attic space, that you'd like to get up top and the ability to insulate it properly, spray foam around it and seal it so that it's air sealed so that you don't get air infiltration around them. If it's something where you're going to drywall over something, a lot of people for years when they had lath and plaster, they put a layer of drywall just over top of it. Now all of a sudden your electrical boxes are recessed in. They make a box that fits on, and this is just a taller one. They make them a 1/2 inch so it fits on the 2 existing screws on a light. Say this was for a light. Extends it so that you can run all of your boxes on, your fan or your lights or what have you, will mount into the original position. They make them in octagon boxes and square, but you can extend them out. And you've got for dryer plugs or your stove. They have a large box. These will predominantly run on 220. That's why you'll see 4 connections here. There will be red, white, black, and your ground. It won't be green, but it'll be a fairly heavy gauge wire that feeds this. Different types of fasteners for fastening the wire along. This was about the most common. It's a staple. Whenever you're running electrical wires new through a house, you shouldn't run them over joists in a basement. They should be drilled through and up over. You never go through a metal ductwork if you're going to run a new line for something. Some electricians still will staple them to the joists. I don't care for it because if anyone ever contacts it heavily or something, you can cut the wire. That's why I like to see them tucked up and run through the joist. If it's just a storage area and that, I guess that's acceptable in that. Electrical wires, if you're going to make a termination where you say you've got an area where you've eliminated something, you cannot bury that. You like cover it over with drywall. Anywhere there's a connection, it should be accessible. If you're going to make a connection, it should go into a box like this. And I don't think I have a cover, but it should have a metal cover over it. If you're going to make any connections in electrical, make certain that it's moretted. A moret is a plastic piece with a very sharp core inside so that when you put the 2 wires together, you twist it on the wires. Losing all my scraps of wire. When they go together, they twist on fairly easily. It makes a contact where it's actually pinched this tight enough that it'll never short. If you come across one that's just a gob of electrical tape over a couple of wires that are twisted together, which wasn't uncommon to find in a lot of older homes.
Can you undo this?
Pardon?
Easy to undo, or do you
Yeah.
go with the wires?
You can turn it off. Like if, say, you wanted to put another wire in there, it just, you twist it until it goes snug. Ideally, if it's a connection that you're going to bury in an area, like say it's a basement where you've run some circuitry to run a plug over to somewhere different, and you've eliminated something. Moret the wires, if the one wire is still hot, moret them, and then I put electrical tape over the end of the morets as well. And it's a good idea if you are not going to be there forever to mark the lines as to where it comes from. Put a piece of masking tape with where it came from. There's nothing worse than finding a bunch of connections somewhere and then you're trying to chase them down as to where they came from or where they're going. I've seen electricians spend hours at $65, $75 an hour trying to sort out wiring where if someone said, eliminated plug in south bedroom, they know where it's going. They don't have to worry about it's another one of those things that years ago, twisting them up and taping them was acceptable. Originally wiring in a lot of houses what was called knob and tube. It was a porcelain tube with a piece of wire that run through it. And they were fastened all the way along through the home. And it was basically wide open other than a little bit of insulation on the jack of wire. That's all there was there. Knob and tube is something that if it's exposed and it's on a circuit by itself, Manitoba Hydro will still accept in a home when you're selling it. I've seen a lot of real estate agents go through and say, oh, that's got knob and tube, and scares off potential sales of a home. You can get a letter from Manitoba Hydro. If you're at all worried about it, have them come in and do an inspection on it, and they will give you a letter certifying that it's been inspected by Hydro and that it is still acceptable to be left there. A lot of homes years ago were renovated in areas and had new wiring put in, and they've left knob and tube in, say, the basement, or sometimes in an attic space. But as long as it's on a separate circuit, Manitoba Hydro will still leave it as an acceptable piece in the home. Those are small things that if you're selling a home can be the difference of tens of thousands of dollars in your pocket, or a potential buyer thinking, okay, I'm going to have to spend a fortune updating this, where it's something that's in a basement that's not going to bother anything. Covers for things. This is an exterior cover. It's weather tight. Anything that's outside is supposed to have a weather tight cover on them. I've seen lots of them broke off of them and that, and Hydro never will say anything. But most homes should have a cover over any exterior plugs. Interior covers come in different sizes and shapes. I have them in plastics and metal. I find utility areas in that predominantly, I'll use a metal one or even just the galvanized ones, because these ones will kind of get grungy and the metal ones will rust, whereas the galvanized one, like in a laundry area, won't. If you're in a higher humidity area, say you have a wash tub or something, in your laundry area where you rinse a lot of things with hot water and there's steam, a metal cover works well. Remember, if it's within 3 foot of a sink or water, it has to be a ground fault plug. Dimmer switches. There's like a ceiling fan. These will go on the one line that you have. You'll notice those are black. And a ground. The green is always the ground. So you would put this on the one side of the power, and then that feeds this. Because you're basically putting a resistor in that circuit. And what these are, if you ever looked inside of them, is, and there'll be a coil that goes here, and this would be your wire, and this would be a wire here, and they wrap the wire around here, and as they get to where they want it to speed up the fan, they'll put the wires closer together. And this has an arm with a contactor that goes across here. So over here it picks up 1 line, 2 lines, 3 lines of the wire that goes through it. So it feeds more power the more loops the wire makes on it through the circuitry.
So you'll have 2 wires?
Yep.
Black, do they go on 2 places?
One comes out here, and the one will take off with the ground. These are the 2 that, so you're running it through here and out this side. Your ground is on the circuit over here. So this just goes along like this as you're turning that knob. And like I say, the more you get over here, the contactor makes contact with more of these lines. So you're feeding more power through it. The amperage goes higher.
But you attach 2 black ones, some
2 wires.
It would be in series with the black wire. A lot of these switches will come with an instruction sheet with them in the box. Don't know if these ones have on the back side. It'll show a picture on the box sometimes of it. And you'll find in our reference book, it will show you them as well. Bathroom fans. I like a timer switch on them. There's nothing worse than someone leaves a bathroom fan running for a day and a half. You're exiting heat. You're exhausting heat. That's why I always like to timer switch on things in a bathroom. Shower will predominantly, if you set them for 20 minutes. Now they make the timers, they look just like a flat panel, and they come with different number of minutes on the timer, and you just push it. And it'll light up as 10, 20, 15. They come in all different configurations. So if you go to the washroom and you've done your hair or shower, you hit 20 minutes and leave, runs the bathroom fan for 20 minutes, exhausts the damp air, and shuts off. It's not pulling the heat from your house and pulling it out all day.
I have an exhaust fan, but it doesn't do anything. Like, I can hear it running, but it doesn't affect the humidity level.
Could be that the exhaust hood on the exterior isn't opening, or it's blocked. A lot of times dusts and lint and that from in a home will be pushed through the fan. If you pull the grid down on the fan, you'll look in the cage of the fan. It could be lint and dust from the home is collected around it. A lot of them have a flapper inside that opens and closes when you turn the fan on. If the flapper has stuck, it may just be circulating the air in the fan and not actually exhausting it from the home. I usually will just take a household vacuum with a brush attachment, take the cover down, vacuum all the fan drum and everything out. There again, if you have an old paintbrush, sometimes you get in there and knock around, make sure you've got it clean. Some exhaust fans for bathrooms are on a plug. You can actually unplug it and pull the motor assembly with the drum right out of the unit. Then you can clean the cage and the drum all of its own. You can take a look at it and let me know if you want. Take a picture, show me what you see up there, and I can advise you as to how to go. It's not a tough one.
So where would, like, I have an existing bathroom fan.
Yeah.
So where would I put this timer? Like, I have a switch.
Switch?
Yeah.
Where the switch is.
So I just install
You'd
that
take the
instead, take the switch
You
out.
would take the switch out.
Uh-huh.
This one has 2 on it. So the switch, the 2 wires that come off of there would go here and here. You put it back in the wall. And then you just turn the timer to where it goes. And it'll run down and then it'll shut off. So if you're, say you're a landlord and you're the one paying the heat, you don't want to have a switch that just turns the fan on because the tenant doesn't care. You know, he leaves it on all day. If it's, say, 20 CFM, 20 cubic feet per minute, that's moving 20 cubic feet per minute of tempered air, like heated air in your home, and exhausting it. So basically, that's your money for heat going out. Whereas if you put the timer on it, and the push button ones now have gotten to be even better. This is an older one. I keep it just for a reference purpose more than anything.
So you're talking like the Vanny?
Yeah.
Okay.
And these sort of things save you money. Like I say, if that exhaust fan is running all day, you know, you sit and think what it would cost to run your furnace for an extra couple hours.
What about fans attached to the light switch? So it goes on the light.
It's a good deal. I find it's a way to make certain that if it's a rental or something, but nothing infuriates me more than in the night, you're sleeping, someone goes to the washroom, when they hit it, the fan starts and the lights go on. And it's a preference for you. I mean, if you're happy enough with that, that's fine. Thermostats come in all different ranges. This is a heavy-duty one. It's used on baseboard heat for a remote thermostat. It's got the heavier leads on it. The other ones will use almost like telephone wire. They use like a bell wire. It's very, very light because they're only controlling a low voltage circuit to the furnace. And you'll find they're like a doorbell wire. They're very light gauge. You can buy timers. I find I like them that if you've only got the 2 wires, you can't do it unless you pull a new wire. I like ones that are powered by the furnace with a battery backup. That way the battery holds the programming you've got in it, but the thermostat's always powered by the furnace. It takes a 5-wire connection for that. A lot of the time, those aren't bad wires to re-pull because they're usually not stapled in a lot of instances. So if you can check them, see if the wire can be pulled back and forth. You take the new wire and you go upstairs where it comes out of the wall and you tape the new one to the other one, like hook the 2 wires, and then tape it, and you can go downstairs and pull the new wire through by pulling the old wire out. Pulls it back through at the same time. Sometimes you got to jockey it back and forth to get it through. If it's been stapled where you can't move it, then you should call an electrician. He would have a long enough drill bit a lot of the time to reach down in the walls. I've got drill bits at home that are about 4 feet long, 4.5 feet long, and some of them can be, and they're flexible. You can see them at Home Depot, has them on the wall. I don't know what they're worth in that now. I've had mine around for quite a few years. You can reach down in a wall through an electrical outlet and drill a new hole and fish the wires. There's lots of different ways of attacking having to run a new wire if you're willing to take that adventure on. Otherwise, you have an electrician come in because a lot of the time they've got all of the extra long drill bits and such that they can. People at the cable company always bother me because a lot of the time they won't run the wire through your house. They go on the exterior of the house. It drives me crazy. Because what happens is they walk around and you say you want a cable on that wall over there. They take the drill bit and they just start from the inside and go straight out the outside. And they're going through the vapor barrier. What fixes that vapor barrier in your wall? You know, to me, that's not the proper way of doing it. Proper way is to try and route it somehow through the inside of the home. But a lot of installers don't want to take that time and effort to go through fishing through spots that are fairly tough. And a lot of the time it will encounter having to drill holes through drywall and drywall repair. They're not equipped to do that. You as a homeowner, if you're willing to take that on and tell them sometime, could you run it over here and I will fix the drywall? It's a better deal than going, nothing drives me crazy than, and my house was an example of it. They had all the wires stapled to the exterior of the house to run to wherever it was. It was done before I moved there, you know, but it's not a good way to do it in my mind.
My house has got new electrical boxes and stuff, and the electrical's been done, but downstairs I have grounds in my kitchen.
Yeah.
But upstairs in the bedrooms, none of them have grounds. So is it easy enough to just run a ground wire? Because there must be a
What
ground.
I've seen done in applications of that, it's tough to pull all the wire through all of the boxes. So what the electrician will do is find the first box on that circuit and pull a new wire down to your panel and then put a GFI in. That way then everything from it down the line is protected by this. That's the only other option without going through the home and replacing all the wiring.
So then, if they did that, then you would, like, my brother keeps on talking to me about a false ground.
Ground fault interrupter.
Yeah.
And that's what this is.
They've just got the outside looking like it's a ground type wire, but not necessarily connected.
Mm-hmm.
But if they did that all the way down the line, then that.
If they went to the first box on the line, and what you have is around your bedroom, your wire would come upstairs and go in, and you've got an electrical box. Around your bedroom. they would have to have the electrician find the first box. You put your GFI on this one, and then everything down that line is protected by that GFI. So if there's a short on anything here, the GFI takes that hit and kicks out.
So question, so she's got that done to her house. Does the electrician have a record of what he did in her home? Like, can she go back and say, do I have?
No.
GFI?
Most electrical companies don't keep records like that.
How could I tell that there should be a wire, right? There, like,
Ideally, if you plug this into it,
it'll tell you.
it would tell you if there's an open circuit there.
Okay.
And there again, they would still have to pull that new wire to the first box on that line. And it would be a piece of wire like this instead of the old 2-wire. That way then you've got protection back to the panel. I've seen in a lot of rental units years ago that was done.
Is that a good way of doing it, or is it?
It's less intrusive. You don't have to tear the walls apart and pull all brand new wiring. See, they'll then put a regular outlet like this in all of the boxes here down the line. But they will use the GFI to protect that line.
I have a question. I have baseboard heat in my
Yes.
house. And my dining room baseboard heater and my living room baseboard heater are on the same thermostat.
Yes.
Would it be easy to split those so that each one knows?
I think it would likely entail having to pull another power wire for the other heater and then one up to a stack. And with them being on an exterior wall, which all baseboards should be mounted, other than a bathroom one, it's kind of tough to pull a wire up there. It can be done, but it's going to be a little more than a homeowner should attack. There is another way where the electrician could put the second heater on the line, a stat on the heater, because some of the electric baseboard heaters had the ability to have a stat on the front of it. But what you would find is if the first heater that's feeding the second one shuts off, that one's not going to go on. And that's why I say to pull a power feed to it is the tricky portion there.
Because I actually don't even turn them on because my living room is extreme. My house is 500 square feet, so my living room is like 2 feet. But so my couch is in front of my baseboard heater. So instead, I just brought an infrared heater that heats that area instead. But if I could split them and actually have my dining room baseboard heat available, it would be nice.
They may be able to use the stat on the baseboard in your living room and feed the power directly through to the second heater and have the one at the behind your couch on the stat. So the power would, you'd have to get an electrician to do that. I could probably figure it out if I looked at how it's wired right now, but sometimes they can be wired in a couple of different configurations. An electrician would likely be able to help you out there.
I have one coming for the bathroom rentals. Maybe I'll
Get them to look at it and see if the availability of a stat on the baseboard is there for you. So then it'd be a case of you turning it way down on the living room side of things and feeding the other one so that that stat would take care of that.
Because would you say a baseboard heater would be cheaper in the long run than an infrared heater?
Is the infrared got a stat on it where it shuts on and off? They're going to be about the same, but I always find the infrared, there's always a fire hazard that is inherent with things like that. They're considered temporary. They're not really designed for continual use in that. And I think you'll find there's probably a notation on it or something that came as an instruction on it that says keep away from certain distance from obstacles and ceramic heaters and that and such usually do say to keep so many square feet around them free for operation.
Okay.
I'm not trying to scare you or anything, it's just
No, this is good.
things that people should know about temporary heating and stuff. Those are the types of things that can cause fires in homes.
So I have a light switch in my living room that I don't know where it goes to. Like, I don't know, like, nowhere in my living room has like a light that goes with this light switch. And outside of my house, there's no
What,
plug-in outside.
what happened years ago, in a lot of homes, they would put a switched set of electrical outlets on the floor, and they would have lamps that were always on, but controlled by the light switch. So what you may find is that you've got two plugs in the, a lot of the time it's the wall away from the window, and it'll be two plugs on that wall. And those plugs will be on the switch on the wall. I would check them on something like that.
Well, I did, because there's an outlet underneath the light switch, and then on the east wall, I guess.
Yeah,
And then there's one on the, well, that would be south wall. And then there's one on the east wall.
and are they on that switch?
No.
They may have been at one time and somebody's taken them off of there. The only other thing is sometimes there was valance lighting that went in over top of a window, and they would sometimes have a wire that ran up there. The other oddity that people would put was clock lighting in kitchens. It's usually a electrical plug in above your cabinetry.
Yeah, I have those, but it doesn't work anymore.
They were probably on another line that's been taken out in the house.
Well, they
Like a-
worked when I first bought my house, and they don't work since.
That would be disturbing to me. I'd be wanting to find out why it's not working.
Like, you're talking the little, like, lights with like a little bulb inside them, right?
No, clock lighting would have been an electrical outlet, almost like that, up above the cabinetry.
Clock actually plugged in.
Clock actually plugged in up there.
I have one, but it's covered
Oh,
over. It's kind of like pot lights, I guess, is what you would call it. There's like little pot lights underneath my cabinets.
Okay.
And then above my sink is there's an outlet like that with two cords in it, two more lights, and then the wire runs down. to my
Okay,
cabinet.
somebody's put like puck lighting underneath
Yeah,
the
that's-
cabinets.
Yeah.
A
But it,
lot of them are on a transformer,
okay,
and the transformer will burn out on them.
okay, so how do I fix it?
So if you chase it back and find out where the transformer is, you can take the transformer out and go to an electrical wholesaler, and they will advise whether they can still get it. Because that was the problem with some of that stuff. It became obsolete. And then you're back to buying the complete set of 4 puck lights and the assembly to put it back in.
Oh,
That's why a lot of the time when I put in under cabinet lighting and that, I'll try and use a strip fluorescent because they seem to last longer and they're a little more readily available than all of the transformers and such with puck lighting. Puck lighting is nice. It works well in areas that you have trouble getting to and that. But I find a small fluorescence, the LED lighting nowadays is terrific stuff. I have an LED external light here that I found for around your door. And then these are just the cheapo jam can type.
well, see, what I was wondering with the light switch that's in my living room is I wanted to know like how I would find out if there's an outlet on the outside of my house underneath my siding.
If it's anywhere to be, if they ever put for Christmas lights, they'd be in the soffit area of the home or right near the very top of by the soffit.
Okay,
That's be where they'd put it if that's what it was for.
okay.
If I put soffit lighting in for Christmas lights and such, I put them in the soffits. I don't like them on the wall.
Yeah, because like I have one on my garage wall.
Yeah,
That's why I wondered if it was like underneath where my
if it's anywhere and it's
where my
to
door.
feed like Christmas lights, they may have put it on the wall right just below the soffit, or it may actually, if you look up on your soffits, there may be an electrical cover on there that you can plug into.
Okay.
I have
Now I've only done this temporarily so that I've got power feeding this. Most people, if you're not comfortable playing around with power, I don't recommend that you do. There are simpler things that you can do in here that aren't going to be a problem. Most homes, this is what configuration you will see. There's a main breaker, which the power comes in from the hydro line. Each side of this feeds separately, like this. That's a bus bar in the center. You'll notice that I have the black leads all powered into the breakers. You have 110 and 110 comes into your home. That's how in a home in North America we get 220 power. You'll find any of the larger double breakers like this that feed a furnace. This is a larger one that fed a furnace. You're feeding 110 and 110 in combination. So that stove or furnace then is powered on 220. That's how they do it. You'll notice on your house there's 2 power lines and a ground wire comes to your house. And there'll usually be just 2 black wires. They'll be in here. After they come through the meter, they'll feed through the meter and it'll come in as a white and a black, and then there'll be a ground that comes in. Your ground will tie in up here, which the panel uses the back screws on this panel. The other side of your bus bar, where the white wires are attached to, are on there. You'll find the power is fed 110 down this side and 110 down this side. It alternates in the panel, so that when you go here, you'll notice. I'll just pop one of those out. You have 110 here and 110 here. A double pole breaker straddles those two. So you're actually pulling 110 on this side and 110 on this side. If it's a single pole like this, it's only on one side. So you're only taking 110 off of it.
So your stove and your furnace, and would your fridge as well?
No, your dryer is your fridge, stove, and the dryer.
Dryer is a different plug.
Yeah.
Anything that uses that big 4-pin plug will be a 220 powered appliance.
See, and my plug for my dryer is actually different. It comes right out. It's on right out, but it doesn't have a breaker. I don't. Well, yeah, it does. Never mind. But it's
Most of
right
them
beside
should.
my block, my box.
Yeah.
My water heater's on.
Water heater will be on 220 as well in some applications.
And it's still got the flip down.
Yeah. And yours would, if it's got the flip downs, it's probably got long fuses that are about this long and almost as thick as my thumb.
You know, I've never even flipped that. And you open
It's a
the button.
secondary panel that's
Yeah.
on. Yeah, and that's a blade terminal, and you'll find that it's probably fused. If you open it up, the fuses are about this long and 3/4 of an inch in diameter.
Yeah.
Not too often will you run into problems with those. Breakers in here, like you saw me pop this one out, they will lock in like this and push in. Now, as long as the main breaker is shut off, the bus bar here has no power in it. So it can't shock you. Stay away from this portion, and you'll be okay. And there again, you would take the lead. You'll notice these ones are into this one. You would back the screw out, pull the wire out of there, and I just pop it like that, and they come out. They come out very easily. If it's this style of breaker.
And so where would you go get a new breaker like that?
Any of the wholesalers, I think Canadian Tire, Home Depot and them still sell them. Home Depot, I believe, keep them by the till in a lock cage. But if you took that breaker, or if you took a look at it and that one's marked as 15 amp on it, they would be able to get you what you're looking for. And like I say, if you've got a breaker that you've been having to go down for the last 2 years and reset, the breaker could be getting quite weak. You'll notice some of them probably it's a little harder to get to reset. You've got to push it a couple of times and it resets. That's usually an indication that the breaker itself is getting weak.
Could there be too much in the breaker box?
You can overload a breaker box, but predominantly no. Most of the time, you can have more breakers that add up to more than this, than a 100 amp service. Say like this is 100 amp. This can add up to more than 100 because not all of them are going to be on at the same time. So if I had a furnace though that took 100 amps to feed it, and the furnace is on, I couldn't turn anything else on in the home. So that's why they're configured this way. I believe this furnace is an 80 amp or 60 amp, so it would have been a smaller version furnace. Might have been like a couple of thousand or 2,500 furnace in a mobile or something like that. I don't even remember where I got the panel from. It was out of an older Renewal, and I've always kept it around just for this. So that kind of gives you an idea of what the internals of this will be. You'll find that's hot on that side, but it's not down there. So there it's hot. So as soon as I put the breaker on, so that third one is dead, so that one would be there. So now I've got that, so I'm feeding these lines. That one is hot. Okay, so that one there I know goes to that, which would have been the exterior light, that there's a wire around the side. So now if you're going here,
Is there no way, like on mine, I have a door and it has where each one is?
yep,
Mm-hmm.
it'll have a legend on it like this that's numbered to the breaker, and a lot of the time I always used to have someone type them out for me because I find a lot of the time they've been written on so many times. What I would do is jot them all down on paper and get someone to make labels for me, typed ones, and put them on. And find it's a lot simpler than trying to decipher 50-year-old writing on it. I use this to find out which breaker and which circuit I'm on. So that one I know is the power that feeds here. That will go to my light switch for up here for the ceiling light, which is this one. This will feed power to either one. So I would tie a black lead onto this one of 3 and then feed these other 2. So you would feed them across. This would be my switched unit to go up to this here or to the one outside.
Oh, because there's two, it's a two.
Because I've got 2 switched ones. This goes to here. And this goes to out here to the exterior light.
And what are the other two for?
This is where I would take power and lead them over to these ones and then switch from this side up. So I would put a Moret with 2 extra wires out of here and then feed off of the switch up. So that's what that would do. So that's a regular switch. That has nothing to do with anything up here. You'll find that circuit then you would put your plug-in on. You will find predominantly your plug-ins are all in a series. You know, there'll be a breaker for a bedroom or two bedroom. Most of the time nowadays they will try and do a single room or two rooms, so you're not exceeding 12 on a circuit.
Well, we've got so much more to plug in now.
And that's the thing. Like years ago, homes had 2 outlets in a bedroom a lot of the time. Now they're no more than 8 feet apart. There should be an electrical outlet. Code tells you now that they'll be 8 feet. And I like to put extra ones in a lot of the time. If I'm going to a bedroom, I'll look where the window is, and usually I'll put one below the window. You'll know there's a bed going to go against the other wall, so set one midpoint out on the wall so that if they're plugging in, or one just adjacent to the doorway. And usually on the wall where the closet is, put one there. So you'll have minimum of 4 to a bedroom. Ideally, you try and not put them close to the corner of the room that's solid, because you'll know the bed will likely go there. And you don't want to cover up your outlets, otherwise you end up running a lot of extension cords then to power things. I find mid-span of the wall or outside the area where the bed would be. If it's a master bedroom, I will put 2 against the one wall where the bed would likely go, and they will be 2 feet in roughly from each corner, and then put 1 over in the other walls. And you try and put the extras in that. How many people have seen an outlet in closets? Sometimes I put them in closets, specifically in hallway areas and that. If you've got like a coat closet or something, if you're dragging a vacuum around, you can open up the closet, plug in, and use your vacuum in that area. It's a simple way to just tie with a bedroom one or something, to have one flipped around. Some people don't like doing it, but I've done it in applications where you don't have one in a hallway and it's a short hallway. I'll pop one in a closet. It gives you the availability of doing exactly like I say, putting it with a vacuum or something in that such. Now, is everyone comfortable then with removing the breaker in the panel that way? Like you say, it shouldn't be that tough. The panel box will have the 4 screws that hold it. Some of them are split. The main breaker will have a separate cover. This one has got the main breaker cover. It splits there, so you can leave the main breaker. And ideally, if you just shut the main breaker off and have a flashlight handy.
Good point.
And then a lot of the time you can take and undo the bottom half of the panel and take it off while the lights are all on. Find out which the breaker is first and put a piece of tape over it or something so you know which one it is. And then when you get in there, you can take a look in there and say, okay, I got to pop that one out. You shut the main breaker off and then just take a flat screwdriver. And you'll notice they can just be pried against like that. And you can pop one out in the middle of things. That one's attached with my wire on the other side. So it's really not that tough to make sure it's locked into the heel of it.
Sure, can I try taking one out?
Yeah, I'd like to too.
you want to pop this one out. And there again, you can just set it there. I've done that. Make sure that that's a hot one, see? As long as you don't touch anything, you're not going to get zapped.
Now I can go.
Yeah. Pry it against the other breaker.
That's why I'm waiting to do my light switch in the hallway.
Yep. And then it's got a heel that it hooks on. You'll find that the breaker, you'll notice how it's like that?
Oh, yeah.
It hooks in that little heel.
Yeah, okay.
So you'd hook it in there. Make sure it hooks on that. They're a little awkward sometimes to pop in. That one's keeps falling, so. There, it dropped in.
Okay. And then you just stick the wire back in it and then tighten the screw.
Yep.
And that's how you replace it.
Now you would slip the wire back in
Into what? Into the little
and snug that up.
Oh, so you can't see that good from the center.
over here.
Is the camera on?
You're fine.
I'm short enough to stand under it.
No, that one didn't go tight enough yet.
Most of the hands-on parts I'll be cutting out anyway, just so nobody's
Oh,
gonna be
that
on
one
TV.
was mine in the right spot.
Yeah, if that's why you're holding back trying this stuff out, by all means, jump right in.
Why didn't you tell us that a long time ago? Like 3 classes, 4 classes.
Because I thought you wanted to be famous.
Not my ass.
And that wire's snug again. So you'd have the main breaker, throw it back on.
Test it. Oh, you don't even have to touch it.
It just even passes near the wire. So these ones are dead. The breaker's not on.
Very easy.
So it's a
That's very easy.
fairly inexpensive, and if you're going to play around in there, like I say, electrical, it can be very, very dangerous for people. If you're at all apprehensive about it, just call your electrician. If it's something as simple as changing that breaker, though, like you saw, it wasn't really that tough in that. I caution people to be certain the power is off. That center bus bar there, that can zap you. And electrical shocks are never fun. I don't know how many of you have actually had that, but it's